Hi, this is Pietro Michelucci from the Stall Catchers project, and I'm here to give all our catchers an update. Stall Catchers has been running for a little over 3 years, and we began the project with an ambitious goal, which was to accelerate data analysis at Cornell's Biomedical Engineering department by a factor of 10. In hopes of reducing the amount of time to analyze our research data toward a treatment target for Alzheimer's from 30 years to about 3 years. Well, here we are at 3 years, so where's the treatment, right? Developing the Stall Catchers platform required a period of validation to make sure that the data coming out of Stall Catchers was actually of a high enough quality to be trusted for developing a treatment target. And it turns out that it is, and we even discovered, as you'll read in some of our blog posts, that the crowd-based results, that your results were actually better in many cases than those developed in the lab analysis. It took about a year to establish the validity of the platform and to come up with exactly the right method of sharing the results from the platform with the lab in a way that they could provide a secondary validation of the crowd-generated data that wouldn't take very much time. Once that was done, then we were operating in earnest, and we were analyzing real data on a regular basis. And over time, we've increased our rate of data analysis from about where we started, which was about half as fast as the lab in our first few weeks, to now about 5 times as fast as the lab. The reason that the lab isn't providing data faster right now is not because the data sets don't already exist. They're sitting there waiting to be analyzed, but there is a step that needs to happen before the data can go into Stall Catchers, and that step involves what we call masking. That is, we want to cover up regions of the imagery of these blood vessels in the mouse brains that don't reflect actual capillaries, that might be larger vessels or regions of the brain called dura, where you might see things that look like capillaries, but they're not capillaries, and we don't want to count those. So it takes some time to actually basically scribble a permanent ink marker over those regions so we don't accidentally look at them. But what we're realizing is that it doesn't take domain knowledge. In other words, you don't have to be a biomedical researcher to be able to quickly learn how to erase the regions that shouldn't be explored in Stall Catchers. And so we're actually now considering making a new Stall Catchers task for players who have demonstrated a certain level of skill in the game and who have a certain amount of experience, who could then move into this other zone and do some of that masking, that digital scribbling out of these regions of the mouse brain, which would then remove this additional bottleneck, and we could potentially get data sets coming into Stall Catchers even faster than they are today. So today, I actually visited with Chris Schaffer and Nozomi Nishimura at the Biomedical Engineering department here in Ithaca at Cornell University. And we talked about that possibility and how that might work. And they were actually enthusiastic about the idea and thought that that it could work quite well. So we're going to continue that conversation and see if we can develop this new mode of engagement with Stall Catchers. So another part to this update is to say, where exactly are we? We were hoping to have identified a treatment target after 3 years. So I went to the lab to get an update about where we stand in the research and how close we are to a potential treatment target that could actually make a difference in people dealing with Alzheimer's disease.
So many of the experiments we've been doing and many of the data that Stall Catchers have been analyzing recently.
Chris reminded me that their overall approach is to look at the molecular mechanisms underlying capillary stalling. So what does that mean exactly, and why would they do something like that? Chris explained that understanding the mechanisms that underlie stalling helps them identify different ways that they could intervene to prevent the stalling from happening.
The approach we've taken to try to figure out the the molecular machinery involved is to look at what other people have done in terms of understanding molecular machinery that leads to other kinds of dysfunctions in the brain vasculature. And my good colleague down at Weill Cornell Medical College, Constantino Iodicola, his lab has worked for a number of years to try to understand what...
Chris and Nozomi have a colleague at the Weill School of Medicine at Cornell who's been looking at, more generally, causes of blood vessel issues in the brain. And so that was their starting point, to look at this model of what might be going on at a molecular level, and then to look at different pieces of that model and see if intervening, if causing a disruption in those parts of the model change what's happening with the capillary stalling. So that's where stall catchers comes into play.
So where we are right now, we've now shown that when we inhibit NOX2, so this NAPDH oxidase is NOX2, that the number of stalled capillaries decreases, brain blood flow increases, and memory function increases. We've similarly shown that when we inhibit PARP, brain blood flow increases, and the data on capillary stalls is being finalized now. And in one other little piece of data, we found that brain blood flow increases when we block a molecule called vascular endothelial growth factor, or VEGF. And again, the capillary stalls follow that same trend. They go down. So putting all this together, we sort of have this picture that...
So they would take a compound such as NOX2 or PARP or VEGF. These might be familiar acronyms if you've been analyzing those data sets in stall catchers. And each one of those would target a different part of this model. And then the question is, are there fewer capillary stalls than without that kind of a compound?
So where we are right now, so this is hypothesis, but where we are right now is we've proven a few of these places. So where you see check marks here, we know that inhibiting VEGF leads to stalls going down, inhibiting NOX2 leads to stalls going down, inhibiting PARP leads to stalls going down. Our next steps...
In each case, there's been a positive result. So this is very encouraging that we're basically barking up the right tree. Chris went on to show exactly where these parts are in the model, and now we have 3 remaining question marks, and each of those is a data set yet to be analyzed in stall catchers.
This would be a fairly detailed picture of the molecular machinery that underlies these capillary stalls. The next step for us beyond that would be critical before you would imagine launching into drug development efforts is to learn which cells these various molecular players are acting in.
So Chris described that once we have that more comprehensive picture, next chapter in this research process would be to identify exactly where this process is occurring. As Chris describes it, there are basically 2 places in a very general sense where it could be happening, either within the brain itself or inside the vasculature. And there's a barrier between those 2 places, and some drugs can cross that barrier and some cannot.
And so if these molecular players are acting on the brain side of the blood-brain barrier, then it might be harder to target those with drugs. And that might suggest that we want to target things that are in the endothelial cell. But on the other hand, if some of this more upstream stuff is happening on the blood side of the blood-brain barrier, it could be good to target a more upstream molecular player. So again, I just, as always, I really appreciate the dedicated efforts of stall catchers, of the stall catchers community in analyzing this data. And this is where we are now with the NOX2, PARP, and VEGF data sets, trying to put it all together to build a comprehensive picture of the molecular machinery that underlies capillary stalls.
So it's exciting to see that there's a real connection between the hard work that you all are doing in stall catchers and the progress of this research. We are making real progress. We have a few more questions to answer to get a complete picture of the molecular model that's underlying capillary stalling. And then once we have that, we're going to try to figure out, is this happening in the brain or the vasculature? And then that would set the stage potentially for some clinical trials with a drug that would intervene in the appropriate place. So I'm very excited and pleased that we've come this far. Obviously, we have a lot of work to do. As I mentioned before, we're trying to figure out ways to speed this up even more by taking some of the tasks that are still slowing things down in the lab and making them available to the stall catchers community, so some of our more expert and experienced players can actually alleviate some of that slowdown, and we can analyze data even faster and hopefully get to a treatment target even sooner. So again, Happy New Year to everyone. I hope everyone is doing well. It's great to see folks playing stall catchers. I like to come to the chat and enjoy some of the friendly banter there. I hope to see you there, and thanks for catching.